All right. So as Harry mentioned, my name is Stuart Laval. I'm with Duke Energy. I'm in the emerging technology office, so we're kind of like the R&D group for the company. Duke Energy is obviously a quite large end user of electricity. So we have to work with our entire ecosystem to really implement a lot of these technologies. I also chair the OpenFMB, which is Open Field Message Bus Users Group. Very similar to the open process automation, which I believe is kind of a big deal here from interoperability perspective. We're kind of going down the same path from a grid perspective. And a lot of the concepts, even in the last presentation, would align with this architecture. And so, before I get into details, OpenFMB is really a framework for interoperability, and our goal is to leverage existing technologies and existing standards where we can, and use that for really an efficient way to federate data securely. And one of the key things for Duke Energy, why we're going down this path, is the ability to enable distributed intelligence or edge analytics. Basic information on Duke Energy. I know my colleague Jason Hanley presented this morning, but we are one of the largest utilities in the country. We serve 7 states, 7.5 million customers. We have about 50 gigawatts of regulated generation. But I think the big disruptor here is renewable energy. We've made a commitment by 2050 to be net zero carbon emissions. And so to get there, we have to make investments into wind, solar, and energy storage. These were stats from last year. I think they're much higher now. But I think the trend is that we're going to be moving away from fossil to distributed energy resources. Before I get into kind of the technical architecture, I wanted to kind of share some observations that we see on the operational technology side as we're trying to adopt some of these off-the-shelf IT technologies. So a lot of the vendors that offer solutions today, I think, still miss the needs of the utility. And so there's a lot of buzzwords out there that we see in the market with their products, but I think there's still, I would say, a gap on meeting the need and what it really means. So kind of define a few terms. So DER management, distributed energy management. Today, what you find is usually load management, so really just trying to have a virtual power plant or shed load, really not integrating the actual sources of electricity back into the grid. Distributed is another term we hear a lot. As I mentioned, distributed intelligence is really the goal of OpenFMB, but we see a lot of either decentralized solutions or hub and spoke. And distributed is really enabling both to coordinate together. Real time is another misnomer in our industry. A lot of our SCADA systems typically operate in minutes to hours. And for addressing like solar energy, where you have clouds that fly over solar panels, we need sub-second decisions. And so that's really how we see more near real-time controls. Also, another misnomer is the concept of peer-to-peer. We tend to hear that term on the telecommunications side, but we really are trying to refer to it on the logical data exchange paradigm. And what we see a lot still in the market today is either a client-server or a master-slave topology. And we really believe information should be federated and decisions should be done at the edge. Grid management is another term we see a lot with our traditional suppliers. Today, they mainly just take back just the SCADA data to be able to manage their operations. But just like we saw in the last presentation, there's a lot of administrative information as well as network management information that's needed to really keep the actual end devices healthy and reliable and resilient. Cybersecurity is another one. From an OT perspective, it's not just network security or VPN tunnels or firewall management. We actually need root of trust. We need analytics at the edge looking for bad actors. We also need isolation from an application perspective. So there's a lot of OT cybersecurity requirements that we're looking at that's still a gap. Historian as well, one of the largest suppliers in the industry is basically OSI Pi in our space. And all that information gets backhauled to the data center, and then it gets ingested, and then in many cases compressed, and a lot of times the data gets lost or is no longer actionable. And in the case of the cloud as well, basically backhauling that data. Where we see the OT world going is having local time series databases and being able to process, store, and also act very quickly at the edge. And going back to analytics at the edge, it's not just forensics or diagnostics, it's really making action and controls. So there's really three major standards in the industry, so really address all the different paradigms in the utility market. The first standard is kind of what we have today. It's been around for 2 decades. Common information model. This is what our typical SCADA systems run. It's a hub and spoke model, command and control. The other standard that popped up about a decade ago is IEC 61850, really designed for the substations. It was really built in Europe, so very different grid topology than we have in the US. That one's really more of a decentralized type of paradigm, where each substation is really not coordinated, but the devices have a very rich data set. And the goal of OpenFMB is really take the best of both worlds and be able to harmonize the two and federate data. So we have the rich vocabulary of the end devices in the substation, but we also can have a common canonical data structure to be able to federate and share data in the back office when needed. Before I get into OpenFMB standard itself, I want to talk about distributed intelligence because it's another misnomer. It's not just edge intelligence. It's really the ability to have a multi-layered, federated architecture that supports active coordination between multiple devices and systems that are working together to solve a common problem or use case. And the US Department of Energy calls that laminar coordination, effectively layers. And it's really having analytics from the edge to the node or the substation, as well as even in the back office, and do it in a way that you optimize the decision based on the use case requirements, then that's set up front. And the biggest value driver is you can stack use cases. And so we can have multi-purpose assets now, delivering stacked benefits. And similar to the last presentation, a lot of in processing at the edge, report by exception, trying to eliminate a lot of that backhaul to more effectively utilize the spectrum and not necessarily relying on the back office for a decision. And the standard for distributed intelligence in the utility industry is the open field message bus. Here's just some references for distributed intelligence. On the one on the left is actually the document from the Department of Energy. There's about actually, I think, a dozen of different documents, but this one in particular kind of sets the stage for the layered architecture that we leveraged. And then the North America Energy Standards on the right. We just published a latest revision to address gaps in cybersecurity and also update some of the new protocols. And that's available through the North America Energy Standards Board. And so the traditional approach in a client-server world is really you make an investment into a single asset, and there's really one single use case or outcome. With OpenFMB and a distributed intelligence model, now you can take a number of use cases that actually meet a variety of scenarios, and that's kind of how we're able to stack benefits. And so the traditional approach, we would have data silos from each vendor's solution, whether it's hardware, software, telecommunications, and the only way to really federate data is in the back office through some type of enterprise service bus. So for when we have a one-way power flow grid, it's probably not a big deal. But when we move to high penetration solar scenario where clouds are moving over solar plants, you may have intermittency. And so to have that data go back through multiple levels of integration before a decision can be made, for example, to smooth out that solar generation, the decision's too late, and it really doesn't, it's not very effective. Whereas what we really need is a way to have ability to contextualize the information at the edge, converting from whatever native standard or protocol as close to the device as possible, and then logically being able to share data between assets and essentially abstracting the logical, the network, and the physical layers of data. And the beauty of this is you can run on pretty much any type of wired or wireless transport, as well as any published subscribed protocol. And we're using standard definitions for the object data models and semantics between the exchanges. And so for the same scenario, you would be able to make a decision locally, but at the same time, actively coordinate with your existing systems so you're not doing it in a siloed manner. And as well, by having grid edge analytics and as well as just the ability to access data at the edge, you can also add some security as well. And so what's really happened on this message bus is you kind of have to define the payload. It's really a standard definition based on the common information model or 61850, and you can also even federate and segment each we call profile. So for example, one profile might be a reading, which is essentially the monitoring measurement data. We could also segment events, alarms, controls as well. So these different profiles actually could be prioritized if you really wanted to with quality of service. And so if we kind of take one step further in terms of different layers, the current state is on the left. Most of our back office systems are called tertiary systems. They operate in minutes to hours. The biggest problem we have today is that our existing distribution energy management systems do not talk to solar, do not talk to energy storage, do not talk to microgrids. They're completely siloed. And so it's very hard to coordinate these renewable generation sources with our existing power grid protection schemes. And so like our new distributed energy resources on the left are not actually sharing data with the existing infrastructures on the right. So in order to augment that, we can essentially add logic as well as applications as close to the edge as possible. Some of those apps may react in seconds, some of them may be minutes. A lot of these devices can all have essentially communications where you can augment with some type of application. And now we're able to share data peer-to-peer, but we don't want to do it in silo from the existing systems. We actually want to coordinate with existing systems. So there will be logic that can convert some of this hub and spoke command and control into what we call schedules. But the only way to really pull off the schedules is to take advantage of your local time series database. And a lot of our cellular radios have GPS, and we're now accessing the precision time protocol clocks, and we're able now to timestamp the end devices. Where we had either no time or limited time precision, now we're able to get time precision in the microseconds, which we're looking at managing a 60 hertz sine wave. I think a microsecond is good enough. This is kind of just a high-level picture of how you would retrofit the existing infrastructure. Within each communication node, you would have applications. One application would be a protocol adapter, another one would be a data model profile, another one would be your publish subscribe middleware. And that's really how you're able to orchestrate the interactions and the secure data exchange. And it can happen in multiple tiers. And within the node, we're trying to build really a best-in-breed architecture. And actually, some of our vendors are actually integrating the entire thing. So I know we saw multiple boxes. Unfortunately, in our space, we can't afford anything over $1,000. So we have to get the cost down. And one of the biggest pain points for our vendors is we're saying we need 4 gigs of RAM. And they don't want to add the RAM because they're focused on just communications or just protection control. They just want to limit the memory to their specific function. So we've finally got buy-in from our leading suppliers to beef up the horsepower, to beef up the RAM and add memory. So now we're able not just to put protocol translators, we're also able to, we're looking at adding the kind of cloud native technologies, such as your, cloud providers technologies, where they have on-prem solutions. We're working on trying to get that IT plumbing into the box. So a lot of the management services for managing containers. So, some type of lightweight container orchestration and running Docker. Mentioned Debian Linux. We tried to go down the path where we worked with each vendor on each Linux flavor, and it just became impossible. So it was actually, we feel it's an easier way for us to kind of bootstrap applications by just saying, put your code in a container. We don't really care what your operating system is. And then that way, you're really just relying on the hardware vendor to manage their device and manage their device. But they provide the container runtime, and then so you can run Docker containers. And either they can provide the container orchestration, or you can work with a IoT provider's container orchestration agent as well. So that's kind of where we see this going long term, and we see a lot of buy-in from our vendor ecosystem. And as I mentioned before, OpenFMB is a framework. I think the biggest value is really the message profiles at the bottom of the framework. These are built off real business cases, real use cases. They're modeled in a standard language called UML, Unified Modeling Language. But ultimately, the format that we have for message profiles, this is the payload on the wire. We serialize the data in Google protocol buffers or Corbett's IDL. And this is really the requirement to get the publish subscribe protocols to be able to transport the data and be interoperable. And we've made the data models, the use cases, and profiles open source with an Apache 2 license, and it's open to the public. And then we let the vendors choose how they want to implement everything beyond that. So really how they want to do the adapters, how they want to do the applications, how they want to manage everything is really up to them and their licensing model. Some are considered open source, some are not. But the beauty is as long as the payload's the same with a Google protobuf file, that's really all you need with publish subscribe. To learn more about OpenFMB, we have a variety of different organizations. As we mature this type of standard, there's multiple different organizations we have to play together. The hardest ones, obviously, the users group and the testing certification authority. Fortunately, it's the same organization, so we can actually integrate much faster. The standards development organization is NASB, and that standard's pretty much been recently ratified. It's set in stone. It's not going to change for a long time. So we feel very good about vendors really adopting the latest release of the standard and essentially going through the certification process. And we have our first third-party nonprofit accredited lab as well, who's committed to provide a test infrastructure to validate conformance to the standard. We had our first interoperability plug fest last year. We had some of the leading vendors in our space bring their technologies and conform to the standard and show the data exchanges, show that they could play together. And one of the great kind of lessons learned was that when you have this type of data model and use case up front, how easy it is to integrate plug and play. As I talked about the other two standards, they also had PlugFest at the same time that week. They took pretty much the whole week to get their stuff to work. Ours took less than half a day. So it just kind of goes to show you this kind of approach of leveraging edge analytics with protocol translation and storage really provides a lot of benefits to the vendors. And as I mentioned, we're focused on certification, leveraging the existing ANSI NEMA processes for interoperability testing and reference some of these more stringent ISO standards for accreditation and certification. So just a roadmap. Our main focus now is getting the infrastructure at the Battery Innovation Center, which is our accredited lab, up and qualified. And then we're working with the UCA users group to finalize the certification program. And we expect the first vendors to be commercially certified by this year. So just some in-flight industry efforts. There's about 5 or more utilities looking at OpenFMB. Their use cases are really integrating DERs for grid scale into the distribution system, both grid scale storage as well as solar. We're also seeing some utilities interested in voltage and outage management where they don't necessarily have a high penetration of solar. And then just in general, as you have kind of these disparate systems like your distribution management system trying to interact with distributed energy resources and microgrids, there really isn't a good way to integrate the two. So OpenFMB is a good way to integrate these centralized systems with the grid edge, but more importantly, doing it in a way that it's going to be safe and reliable and meet the coordination settings in our fault devices. The last two related to microgrids, we've been able to show even in our site in Mount Holly, North Carolina, we can island and reconnect seamlessly with no black start and no interruption. That's just one microgrid. There's been a project being kicked off at the Department of Energy this year where they're going to now look at multiple microgrids, what they're called networked or nested microgrids. And some of the benefits that these utilities have kind of said is really extending the capability to support traditional systems, but also adding the visibility and performance to their power operations by having more precise controls, fast response times, and being able to use edge intelligence. One utility pretty much has an entire underground system, fully meshed from a grid topology, and they have a lot of congestion. And to really alleviate capacity issues, they want to use OpenFMB to really provide an auto remediation scheme. And a lot of the other benefits are kind of native to kind of this architecture, harnessing edge intelligence for resilience and scalability, low latency, and then kind of the other two things is trying to, get to a point where we can now enable market participation between demand response and distributed energy resources, because today they're really completely siloed. And last but not least, I think this is the hard one for the utilities, is how do we have a very flexible interconnection of distributed energy resources like solar or batteries or microgrids. And today, I don't think we figured that out yet, but we think OpenFMB can certainly help the process. To learn more about it, our microgrid specifically, there's a T&D World magazine in 2017, and then we had a new article come out last March, which kind of goes into a platform built on top of OpenFMB between Duke and Avista Utilities. And there's more information if you want to learn about OpenFMB. And my last slide is really just to show kind of information how you can gain access to the community for OpenFMB, whether it's purchasing standard, getting access to the repositories, the open source content. Also, there's user group site. And then if you're interested in attending an event, our only event this year is going to be in April. It's going to be the 28th and 29th of April in Indiana. It's at the actual third-party test lab. Our hope is that we'll basically get consensus on the infrastructure and the interoperability testing process and program. And if you want to inquire about joining, feel free to contact the email address at the users group. So that concludes my session. I appreciate the opportunity to speak, and I will answer questions, I guess, after the next speaker completes.